Now let's solve question number 18. This question is from chapter circles, and the question says in figure 2 PQ is a chord of length 8 cm of a circle of radius 5 cm and center O. The tangents at point P and point Q intersect at point T. Find the length of line segment TP. TP is one of the tangents drawn from this external point T to this circle at point P and Q. Before solving this question, we need construction. We have to join point O and T with help of a line segment, and this is the step of construction. Now you can see that this point M will be the midpoint of this chord PQ, or you can say OT will be perpendicular to this chord PQ. Why? Because in triangle PMT and triangle QMT, both the triangles are congruent because PT is equal to QT, tangents drawn from external points are equal in length, TM common side, and angle PTM is equal to angle QTM because tangents are equally inclined to the line segment joining the center of circle and the external point. That means we are talking about these two angles are also equal. Clear? So you can clearly conclude both the triangles are congruent, so that you can write PM is equal to MQ and this line segment TO will be perpendicular to this chord PQ. So if M is the midpoint of this line segment PQ, then you can clearly find the length of line segment PM is equal to half of the length of this chord, that means 4 cm, and we already have the radius of this circle. Now using the concept of Pythagoras theorem, you can obtain the length of this line segment OM, which is equal to 3 cm. Clear? Now we have the length of line segment OM, and what we have to find in this question? The length of line segment TP. Now we will use the concept of similarity in two triangles. That means we are talking about triangle OMP and triangle OPT. Both the triangles are similar. Why? Because angle OMP is equal to angle OPT equal to 90 degrees. Angle MOP is equal to angle POT common angle. So in the next step of solution, you can write both the triangles are similar using AA similarity criterion. That means triangle POT is similar to triangle MOP. And you know that when two triangles are similar, then their corresponding sides are proportional. So you can further write TP upon MP is equal to OP upon OM. That means TP is corresponding to side MP, so their ratio is equal to OP upon OM, and we have the length of line segment OP, PM and MO according to the given question. And when you put the values of OP, PM and MO in this equation, you will obtain the length of line segment TP is equal to 6 and 2 upon 3 centimeter. That means 20 upon 3 centimeter is the answer for this question. I hope you understood this question based on the concept of circles. Now let's discuss the marking scheme of this question. So the step of construction will give you 1 mark for this question. Clear? And when you obtain the value of OM, that means the perpendicular drawn from the center to this given chord, this step will give you half mark for this question. Clear? And when you prove the similarity in two triangles, that means triangle POT is similar to triangle MOP, this step will give you another half mark. And when you obtain the relation in corresponding sides of two similar triangle, this step will give you another half mark, and final half mark is based on the final answer of this question. That means the length of line segment TP, which is equal to 20 upon 3 centimeter. I hope you understood this question. That means you can say the length of this line segment TP is equal to 20 upon 3 centimeter, as well as the length of line segment TQ is also equal to 20 upon 3 centimeter. Now let's proceed to the next question. Now let's solve question number 19. This question is from chapter triangles. Again, in this question you have choice. You can solve either this given part or its optional part. So the question says, in figure 3, angle ACB is equal to 90 degrees. That means triangle is right angled at vertex C. Further, this question says CD is perpendicular to AB. Prove that CD square is equal to product of BD and AD. Now let's solve this question. First of all, we are assuming this angle A equal to theta. If this angle A is theta, then this angle B will be 90 degrees minus theta, because this triangle is a right angle triangle. So here it is given that CD is perpendicular to AB. That means angle CDB is equal to 90 degrees. And if angle CDB is equal to 90 degrees, then angle DCB is equal to theta, because the sum of all three interior angles in a triangle is equal to 180 degrees. Similarly, you can also obtain angle ACD, which is equal to 90 degrees minus theta. Now we are going to apply the concept of similarity in two triangles. That means in triangle ACD and triangle CDB. So in these two triangles, first of all, you can see that here angle CAD equal to angle BCD. Second thing, angle ADC is equal to angle CDB. That means using angle similarity criterion, you can prove these two triangles are similar. That means triangle CAD is similar to triangle BCD. And friends, you know that when two triangles are similar, then their corresponding sides are proportional. That means in the next step of solution, you can write AD upon CD is equal to CD upon BD. And when you cross multiply, you will obtain CD square is equal to AD multiplied by BD. This is the required result. And here in this way, you can solve this question based on the concept of triangle. Now let's move on to the marking scheme of this question. So when you find the relation in the different angles of this triangle, this step will give you half mark. Clear? And when you prove the similarity in two triangles, that means triangle CAD is similar to triangle BCD, this step will give you 1 mark for this question. And when you represent the relation between the corresponding sides of two similar triangles, this step will give you 1 mark, and rest half mark is based on the final equation. So in this way you can solve this question, and this is the correct marking scheme of this question based on the concept of triangles. Now let's move on to the optional part of this question. Again, this question is from the same topic, triangles. In this question, it is given that if P and Q are the points on side CA and CB respectively of triangle ABC, right angled at C, prove that AQ square plus BP square is equal to AB square plus PQ square. In this question, diagram is not given. So first of all, let's draw the diagram that represent the given informations in this question. And this is the diagram. The triangle ACB is right angled at C, and point P and Q are lying on side AC and BC respectively of this triangle ABC. Friends, for proving this result, we need Pythagoras theorem. And you have to apply Pythagoras theorem first in triangle ACQ, then in triangle BCP. So let's apply Pythagoras theorem in right triangle ACQ. And using the concept of Pythagoras theorem, you can write AQ square is equal to AC square plus CQ square. Now again, let's apply the concept of Pythagoras theorem in right triangle BCP, and using this theorem, you can write BP square is equal to PC square plus CB square. And you have to show that sum of AQ square plus BP square is equal to AB square plus PQ square. That means we have to add equation number 1 and equation number 2. so that we can easily obtain sum of AQ square and BP square on the left hand side of the equation. So when you further add these two equations, you will obtain this equation. That means AQ square plus BP square is equal to AC square plus CQ square plus PC square plus CB square. Now let us focus on this right triangle PCQ. In this right triangle PCQ, you can replace PC square plus CQ square by PQ square, again using the concept of Pythagoras theorem. That means PC square plus CQ square will be replaced by PQ square, and you can also replace this AC square plus BC square by AB square in complete right triangle ACB using the concept of Pythagoras theorem. So in the next step of solution, you can replace this AC square plus CB square by AB square and CQ square plus PC square by PQ square. That means in the next step you can write the right hand side is equal to AB square plus PQ square. Again we are obtaining this expression using the concept of Pythagoras theorem. So I hope you understood how we can prove the required result. Now let us move on to the marking scheme of this question. So the diagram is not given in this question, so when you draw the correct diagram, this will give you half mark for this question. And when you apply the concept of Pythagoras theorem in triangle ACQ, this will give you another half mark, and when you apply the concept of Pythagoras theorem in triangle PCB, this step will give you another half mark for this question. And when you add equation number 1 and 2, this step will give you another half mark, and rest 1 mark is based on this final step. So in this way you can score 3 out of 3. I hope you understood this question as well as the marking scheme. Now let's move on to the next question.